Okay, if you're rolling out a network, by the time you get to this point, you're feeling pretty good. You got that warm, fuzzy feeling. Things are routing. It's working successfully. It seems like everything's on the right track. In my mind, this is about the final phase, which is going to be services, which I'm going to focus in on one specific service, which is critical, and that's DHCP. And then security, locking things down. Security is always the last thing I do because you want to make sure everything is working before you put the restrictions on, because chances are something's going to break when you put the restrictions on. And you're going to, oh, okay, well, that's because I just did this. Whereas if you mix security in, like you do it kind of midway while you're doing routing protocols and stuff, and something's not working, you don't know which way to go. Is it something I blocked? Is it OSPF isn't working right? It just adds too much confusion to it all. So always do an overlay of security when it's all said and done. So at this point, in my mind, I'm thinking this is going to be the final phase, which will complete our branch lab rollout, unless I get some feedback from you guys at the last minute saying, oh, we really wanted to know about something, and add it in there at the end. But I think this will be the final phase, so let's bring over the lab. I'm walking around. I got to sit down here. All right, so phase 6, configuring DHCP services and security. So we've got the Nugget Labs branch rollout is successful. And let me shrink this down so it all fits. There we go. All devices are communicating across the network. As the final phase, we need to engage DHCP services for the VLAN. And in addition, you must now roll out security to protect the voice VLAN, server VLANs, all the necessary security that was talked about from the beginning. Now, a couple thoughts on this. A lot of times, and actually, maybe, did I put this in the original scenario? I'm not too sure at this point. But a lot of times, when you are rolling out DHCP, the Windows guys want it. They want to run the DHCP server because it kind of crosses into their territory a little bit. If their Windows workstations can't get an IP address, they've got to be the one to troubleshoot. They don't want to get with the network guy. But I will say I've also been in plenty of scenarios. As a matter of fact, I just rolled out a group of charter schools about 2 weeks ago, and I was configuring their corporate office, and I was working with the Windows admin there, and I said, well, I think it's all set up. I said, do you want to do DHCP, or do you want me to set up the firewall to hand out IP addresses? Thinking, in my mind, I was thinking, oh, okay, this is going to be a no-brainer. He's a Windows guy. He's going to say, I want DHCP. And he totally blew my mind. He's like, no, you totally take care of DHCP. If you want to run it, it's all yours. So there's a lot of times where the Windows folks will say, yeah, you do it. And so in our case, there's a couple places that we can do it. The most logical place is going to be right here for the branch office. We've got our layer 3 switch. Because it's a layer 3 switch, it has the ability to be a DHCP server for every single VLAN that it supports. Now, another place that we could do it right here is going to be right here at the router. Is there one that's better? The layer 3 switch seems more logical to me when I'm thinking about it, but it's totally fine to happen right here. But I want to talk about a concept which it's not CCNA specific. No, it wouldn't be on there, but it is everywhere. Seriously, everywhere in the real world. Matter of fact, some of you might have even heard about it. Something called a helper address. You ever heard of that before? Helper address. So here's the scenario. We've got a point-to-point subnet going on between switch 1 and router 1. This was the 10.1.254. I'll just put 0/30 subnet. That's going on between these two guys, allowing them to communicate. Well, we've got all of these different VLANs down here, right? And he's got all the VLAN interfaces. We've got VLAN 64 for the data, 66 for the voice, and so on and so forth. Well, if this guy is your DHCP, let's say we set him up as the DHCP server, this guy's going to send a broadcast coming in, and it will hit VLAN 66. Now, that's going to be on the subnet 10.1.66.x. I think that was the data subnet that we created, I think /23 as a subnet. Now, the goal of a router and a layer 3 switch breaking into VLANs, its number one goal is to stop broadcasts. They are anti-broadcast measures. That's what a router does, is it blocks broadcasts. They stop here. Or in this case, they stop here. And a DHCP request is a broadcast message. So if this were my DHCP server, now again I'm back to the big if this were my DHCP server, the router was, or even I mean if the Windows guys did want to take over and they want this to be their DHCP server, either way it's the same config. You've got to go underneath interface VLAN 66 or the routed interface for that VLAN and use something called a helper address. Now what is that? What it is it takes a DHCP broadcast along with some other broadcasts. I mean, there's actually like NetBIOS. There's I think a list of about 8 of them that it takes by default. But I will tell you, almost everybody uses this thing exclusively for DHCP. It will take that DHCP broadcast message and forward it as a unicast, a directed message wherever you tell it. So here, let's play this out. Let me give it a little space to work with here. Or a lot of space. What will happen is this guy, our little host down at the bottom, will send a DHCP request saying, "Hello, I need an address, DHCP." Now that's a broadcast. Normally that dies as soon as it hits that VLAN 66 boundary. But instead, I went on to the switch and I typed in the command. It's actually I would go under interface VLAN 66 and I would type in the command IP helper. I'll just put help-address. It's a full command. It's helper-address. And I would type in 10.1.254.2. I think this guy's .2. He might be .1, but if he is, then just flip that. .2, because what's going to happen is this guy's going to say, "Hey, I need an IP address." This guy says, "Whoa, sorry, I blocked broadcast." But wait, I've got a helper address configured under interface VLAN 66, the VLAN that you're on. You following me here? The VLAN that you're on has a helper address. I'm going to grab that DHCP request. I'm going to translate it into a unicast and send it directly to this guy. Now this guy will have all the DHCP, they're called DHCP pools. He'll have a whole pool of addresses that he hands out. He'll be like, okay, I've got 10.1.64.0 through 10.1.60, but all of these different pools that he's got. And what he's going to do is he's going to say, okay, I'm going to grab an IP address from the pool that you belong to, 10.1.66.x/23. And we haven't configured the pool yet. I'll show you how to do that in a moment, but I'm going to pull an address from there, hand it back to the switch, who kind of acts as like an interim, an intermediary, a proxy, if you will, and says, okay, let me hand it back to you. And he gets an address. So he kind of brokers, if you will, the deal. He takes all the broadcasts and turns them into unicasts or directed messages to the DHCP server, whether it be the router or the Windows server. And all they have to do on the Windows server or on the router is set up all the pools of addresses that you hand out. Now, let me bring something up that confused me seriously for probably 2 years. I think I just back then had too much pride. I couldn't bring myself to ask because I didn't want to look stupid. But it really isn't a stupid question at all. I found so many people that didn't know the answer as well. I thought, okay, I don't get it. I've got the PCs on VLAN 66. I've got IP phones sitting on VLAN 64. I've got public Wi-Fi devices sitting on other VLANs and all that. I've got all these things, and they're all just sending a broadcast saying, "Hey, I need a DHCP address." They're all saying, "Hey, give me an address, give me an address, give me an address." This guy, my layer 3 switch, sorry, it's getting a little gummed up here with all my drawing, but he forwards it over to the helper, the DHCP server, whether it be the router or whether it be the server. So my question that just haunted me for years, I just couldn't figure it out, is how does the DHCP server know which pool to pull from? Do you see my confusion? I know some of you are like, well, I know the answer. Well, I didn't. And maybe you don't. How did it know, oh, that came from a phone, so let me pull from the 64 pool, versus, oh, that came from a PC, let me pull from the 66 pool, to give them an address on the right subnet. From the DHCP server, it's just a bunch of pools, right? Well, here's how it works. When you set up a helper address, you do it under the individual VLAN interfaces, VLAN 66, VLAN 64. So when this guy, and hang on, I need a clean slate here. So when this guy, the switch 1, gets that message and forwards it over here, he's going to actually send it from a source IP address of whatever that interface was. So for instance, I said it was under interface VLAN 66. It will source the packet to router 1 from the IP address assigned to interface VLAN 66, which will be the right subnet for, of course, VLAN 66. So when router 1 gets it, he says, oh, I've got a DHCP request from the source IP address 10.1.66.1. Oh, okay, well, I'll look at my pools. Do I have one? Oh, there it is. 10.1.66.x. That's the pool I need to pull from. Let me give him an address from there and get it to the right place. For years. I'm telling you, that confused me. So hopefully if you were stuck on that as well, that helps you out. So with that being said, that's some alternate strategies to assigning IP addresses is by going under the switch and using a helper address to point it to a central DHCP server. But in my mind, that guy's the most logical DHCP server in the world because he's got connectivity to everything. He's kind of the core of the network. He's the core switch. So back to the lab. It says, first off, for testing purposes, assign the PC1 to voice VLAN 64 while keeping PC2 assigned to the data VLAN 66. Grabbing my little exercise ball. I have now used this. I have sat on an exercise ball as my chair for the past 2 years. Because someone told me that when you sit on an exercise ball, it totally increases your core ab strength because you kind of, there's no backrest, you just kind of have to sit there. And after 2 years, I can tell you I do not have ripped abs. I was totally expecting to have that after a couple of years, but nonetheless. Although I will tell you, I did have some awesome experiences with my cat jumping on my lap while I'm sitting on here and his claws going into the ball. That is a negative aspect of using a balance ball. So where was I? Okay, yeah, we're back in the lab. For testing purposes, PC1 in VLAN 64, PC2 in VLAN 66. Let's do it. So PC1, I've got GNS3. Let's get a console connection down here to switch 2. Get the size to the right window. And all we're doing is making sure we're putting him in VLAN 64 so we can test to make sure that the voice VLAN does get IP addresses. And same thing, PC2 is going to just stay in the data VLAN. So let's go down here to switch 1. Do a show VLAN, I think it's switch, yep, right here. So we've got all these guys in the data VLAN. I don't remember which port PC1 was connected to. So let's do a show CDP neighbors. That's the quickest way. PC1, right there, connected to fast Ethernet 1/2. Interface, fast Ethernet 1/2. Switch port, it's just second nature. I always type in switch port mode access, but I'll do switch port access VLAN 64. Done. Go back up there, do a show VLAN, make sure that's indeed active. And now we've got VLAN 64, the client voice. So we've moved him into the voice VLAN. So now he can be our test case to make sure VLAN 64 does indeed get IP addresses. Okay, so that was simple for testing purposes. Okay, so it says configure switch 1 as the DHCP server for the branch office network using the following parameters. So let's read through this. VLAN 64, 66, 69, and 70 should support DHCP services. Okay, so that immediately tells me Notepad, we've got a bunch of duplicate work to do for that. It says in the initial testing phase, each VLAN should initially support, I've got a double initial there, support DHCP addresses assigned from the range 10.1.x.10 through 10.1.x.100 with the correct subnet mask and default gateway. Okay, so we're handing out about 90 or so IP address 91 IP addresses to the devices that we'll be setting up for each VLAN. Good. Voice VLAN should also support DHCP option 150 TFTP. So I added this in here not only because it's real world, but because you'll see this all the time. Let me show you an IP phone, kind of how it works. When you plug a phone, and all phones, not just Cisco phones, almost all phones work this way. When you plug a phone into the network, it works just like a normal computer. It's going to go out and ask for an IP address. It's going to say, hey, I need a DHCP address, and it's going to get an IP address. But the second thing it needs to know is, well, I need to go download my configuration file. Meaning, I'm a phone. I don't know what to do. Someone needs to tell me what call manager server to go to, or what management device, or what my phone number is, or all those kind of things. He's like, I'm just a phone. Tell me what to do. So one of the common things, and the option will either be, at least in my experience, across different vendors, either DHCP option 66 or DHCP option 150. So what you do is you go in, configure your scope. You say, okay, hand out these IP addresses, hand out this DNS server, hand out this router, and all that kind of stuff. And by the way, I don't know if you knew this, but when you configure a DHCP scope, everything is an option. For instance, when you say hand out a default gateway to the client, you're actually saying, well, hand out, I think it's option 3. Is the default gateway. And when you say, oh, you want some DNS servers, that's actually DHCP option 6. You just never see the numbers because they have the friendly names when you configure it. But option 150 is known as the TFTP server. Now, that should be a familiar term in your Cisco vocabulary at this point, because what happens is, and I'll go Cisco specific on you, Cisco IP phones will get a DHCP address, and in that response, it says, oh, here's your IP address, here's your mask, subnet mask, here's your gateway, and by the way, here's also option 150, the IP address of the TFTP server, so you know where to go to get your configuration file, right? So he's going to go out and say, oh, okay, TFTP server, tell me my configuration, and the TFTP server replies and says, here you go, and gives it its configuration. So that's the idea of why we have that option 150. I threw it in there just because you will see that in the real world all the time. I wanted you to know what it was. So that's that. It says all devices should use 4222 and 4223 as their primary and secondary DNS server. And then once you've configured DHCP, configure PC1 and PC2 as DHCP clients and verify they receive the expected IP address assignment. Good. So this gives us the true scope of what we're trying to do, because this next piece, I'll probably do this in the next nugget because I'll need some time for that. Configure the security restrictions. So this is all DHCP, and we'll kind of take that all on at once. So I'm bringing up GNS3, and let's move over to switch 1. Bring up a console connection there. So we've got switch 1, getting global configuration. All right, so we've got switch 1. First thing we're going to do is, let's see, we've got VLAN 64, 66, 69. So let's do a show IP interface brief. If there's one thing you've gotten out of this series, it's show IP interface brief every time, all the time. So we've got VLAN 64. Show run interface VLAN 64. There's our correct subnet. So let's do it. I'm going to go into global configuration mode. Now, when configuring DHCP on a Cisco device, it seems kind of backwards, but the first thing that you need to do is tell it what not to hand out. No, it seems bizarre. Instead of saying, okay, I want you to hand this out, you have to say, I don't want you to hand this out, and then everything else is fair game. Because when you go in, let me show you. I'm going to here's how you configure a DHCP pool. I'm going to type in IP DHCP pool, and you give it a name. It can be any name, and I'll stick to nice simple names. VLAN 64, all capitals. Hit enter. I'm now in DHCP config mode. So when you're going through and these are all your DHCP options. You can say, okay, I want to give our clients the default router, such and such. I want to hand out the network, such and such. Well, here's the big problem. You will say, okay, I want to hand out the network, and then hit the question mark, and it says, well, what network do you want to hand out? And I will say, oh well. That would be 10.1.64.0. And it says, okay, well, what mask do you want to use? Or one of the very first places Cisco has ever allowed us to use the bit notation or CIDR notation, where I can say /23, or I could type in 255.255.254.0 as a mask. But notice this, I hit the question mark and there's nothing there. You just hit the enter key, and what Cisco's device will start doing is start from the very first address, which will be .1, which would conflict with the default gateway, and start handing them out. Now that's not good, because you're going to get conflicting addresses. Now, I will tell you, the DHCP server recovers, because part of the DHCP client process is if it ever gets an address, it's going to test it first and say, okay, is anyone else using it? And if it is, it's going to tell the DHCP server, hey, this is a bad address, and so that's fine. But I mean, here's the big problem: is as soon as you hit the enter key on this command, It's go time. DHCP servers handing out addresses without a default gateway, without DNS servers, starting from number 1. I mean, it's going. So once you hit enter, I mean, clients, if you've got hungry clients out there saying, give me an address, give me an address, give me an address, they're pulling your whole pool. So now you're like, oh, whoa, 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 no, back, back, back. So the point is, before we ever go that far, we need to configure what's called IPDHCP excluded addresses, meaning these are the addresses I don't want to hand out. So I'm going to hit the question mark here. Let's do the low address. It'd be so nice if they let us type in a range, right? I want to hand out 10.1.64.10 through 10.1.64.100, which is the range that the lab was calling for right there. But it doesn't let you do that. So instead, what we got to do is say, well, here's what I don't want to hand out. 10.1.64. Well, let's just go with 1 through, well, hang on, hit the question mark. What is the high app address? 10.1.64.9. Because remember, the lab told us to start handing out from 10. So we hit enter. That's our first excluded address range. Now you might say, well, what about past 100? Well, we got to do one for that too. Just hit the up arrow. And we'll say 10.1.64.101 because it said the range should go through 100 right there. So we'll say at 101 through 10.1.65.255 is also excluded. Seriously, that's what you have to do. So now when I type in this network command right up here, like we were doing, it will automatically filter out these and these from being handed out. Kind of a strange backwards way of doing it, but the first thing I'm going to do is do a show run include IPDHCP because I want to grab these guys, throw them in my notepad document right there, and start. I got to create an answer key for this and start doing this for all the VLAN. I'm going to say this will be 66.1 through 66.9, 66.101, 7.255 because that's my data range. So I'll just do, this is our data VLAN. This is our voice VLAN. My wife took off to go do some errands, so I have she calls my parenting style baby gates and veggie tales, which I put up baby gates to keep our little infant boxed away and turn on a Veggie Tales episode. But nonetheless, it's just funny because he's figured out how to open and close doors, so I hear him open the door and just giggle behind me. So it's giving me a good smile. So we've got data VLAN. Okay, so what else? It said VLAN 69, which let's do a show run VLAN 69. Oop. Interface VLAN 69. So that's our public Wi-Fi. So that's going to be 69.0. So let's just do public Wi-Fi. We'll do 69. And that's a /24, so I'm just going to do through 69.255 right there as excluded. So you see what I'm doing right here. I'm just going through and creating these. So let me pause and I'll get the final one created. There we go. So we've got the private lab now created, and now what I can do is take all these guys. So we created the voice one manually right there, and now I can just blast in all of the new ones. So those are now all created. I can go back and do a let's just do a show run include IPDHCP, and we should see all our excluded ranges. Now we can go in, there they are, and now we can go in and create our scopes. So we've got, I started one, IPDHCP pool VLAN 64. Let's come back here. That'll be where we begin. So let's go underneath there so we can use our question mark to walk us through it. So the first thing, I save the network command until last because as soon as I type in network, it's going to start handing out IP addresses. So I'm going to start off. Let's start off with the default router. That's our default gateway. So default router for this subnet will be 10.1.64.1. Enter. Let's hit the DNS servers, and I'm looking right here. It says DHCP should include the subnet mask, the correct default gateway. The voice VLAN, which we're configuring right now, should also use the option 150 for the TFTP server, so we'll remember that. And down here is our DNS. So let's get DNS, since we've got a nice little shortcut for that right there. So I'll do DNS server, question mark. We'll do 4.2.2.2, question mark, 4.2.2.3. So that's the primary and the secondary DNS server that I'm handing out there. And then the last one I'm going to put under the voice scope is that option 150. Now, they don't have a nice convenient TFTP in this list, so this is one that I have to manually configure using raw DHCP options. Now, if you're ever curious, like I said, everything is a DHCP option. Matter of fact, let me just pull up Google here and do DHCP options. Let's just go to network sorcery. Yeah, look at this. So right there, option 1, that's the subnet mask. Option 2, that's a time, obviously deprecated, no longer used. Option 3, hey, I was right. It's the default gateway or the router. Option 4 is if you want to send a NTP or a time server to something. Option 5 is, I think, WINS, a WINS name server. Option 6 is DNS. So for instance, I could have, instead of typing in DNS server I could say option 6, question mark, is IP addresses, and then done this like that. That is an equivalent command to this. It's just Cisco and almost every other vendor out there creates a friendly way of doing this because they realize not everybody knows DHCP option 6. So let me go back, and we're going to do option 150. IP address, and I got to go back to the lab. So we said the TFTP server was this guy right there, 10.1.68.8. So we'll paste that right in, enter. So that's now handing out that IP address as a TFTP server for switch 1. So that should be good. Let's do a show IP, show run section IP DHCP. Let's do pool, so it just filters it down. There we go. So we've got VLAN 64. Here's the beauty of this: is I now go in. Let's just replace all that and paste it in. Now you can see how easy it's going to be for me to create the other VLANs. Just get some tab that's a little off, but I'll do 66. Oh, don't forget the most critical command. We've got to go in and actually remember the one I said I do last, network. I'm going to say this is going to be for the network 10.1.64.0, and just because we can, let's do it /23. It's one of the few commands that allow our bit notation as this. So now we can do a show run section IP DHCP pool. Really? Maybe it just doesn't like it from that configuration mode. That's interesting. Oh, I bet you there's a command that starts with DO under DHCP config. I'm curious. All right, so there we go. Now we got the real config going on, including the network. So now, by the way, that pool is active. It's handing out IP addresses for us to use. So let's get these guys pasted in there, and then we'll do VLAN 66. Actually, let me just paste all these in. All right, there we go. So I've just pasted and just modified. Notice 66. I just changed the networks and all that to the right direction. VLAN 69, got 69 in there. 70, got 70 in there. So now our pools should be ready to paste in. I don't need option 150 for these other ones because we don't have any phones on those VLANs. So jump back to switch 1, global config, and paste away. There we go. We've got all our DHCP pools created. And now let's go back here, and it says once you've configured DHCP, configure PC1 and 2 as DHCP clients. Well, PC1 and PC2, are really routers, so let me show you how to do this. Go into the console port. Now, PC1 should be on VLAN 64. So let's do a show IP interface brief. Notice we've got this. This was, I think, from our original lab when we were setting this up, the IP address that we statically assigned it. So let's go under fast Ethernet 0/0 and do, it's just IP address, DHCP. And then hit enter. And so that will now change it to DHCP. Notice method is DHCP. We're currently unassigned. We should get a console message or a syslog message when we get an address. Oh, there, right in the, I was too impatient. There, we've got an address assigned. Notice it's 10, right? The first one we were supposed to get, the first one assignable from the pool, and there's our syslog message. It says, I just received the DHCP address 10.164.10 with the right mask. And this is the right VLAN, right? 64's voice. Host name PC1. Sweet. Let's go over here and hit PC2. Oop. Ooh, did I? Oh, there is no enable secret on these guys. Let's do just see what it is right now. So we've got fast Ethernet 00, and I'll do IP address DHCP. Now this guy's on VLAN 66, so he should come in under that interface, the VLAN 66 interface, and get an address from that subnet. So currently unassigned. I'm waiting with bated. Oh, there we go. Ah, look at that. Assigned 66.10. It's the first one. So I do a show IP interface brief, and we've got the first address from our pool. That's awesome. So now what we can do, let's just I'll show you a command to verify it, so you can see what addresses have been assigned. I'll do a show IP DHCP binding from switch 1, who's our DHCP server, and you notice we've got 10.164.10. Woohoo! Look at that. That is the most whacked out MAC address I've ever seen. I'm guessing that's something GNS3 is doing with its magical GNS3 stuff, because that's normally, by the way, the MAC address of the client, which if MAC addresses were that long, that would be painful. So and then we've got the lease time, January 12th. We even got the right time. Look at that. So yeah, that's good. So that's, I mean, that right there is a working DHCP server for our network. So good. I think at that point, what I'll say is that's a good place to summarize here. In the next nugget, we'll get into all the security restrictions. But for now, I hope this has been informative for you, and I'd like to thank you for viewing.